Binomial expansion. Let n be a positive integer, then a plus b raised to power n becomes this. This is combination, n combination 1, n combination 2, up to n combination r. They are called coefficients of the expansion. N combination 1. So they are called coefficients of the expansion. And we have treated the combination before. Now, binomial expansion, what is it all about? If you want to expand two functions like this, function A and function B, to power of n, we want to expand it. That is when we normally apply this binomial expansion, or we call it binomial theorem. We call this thing binomial expansion or binomial theorem. Now, we said all these combinations that you have here are called the coefficient of the expansion. But in order not to stress ourselves finding these combinations that are here, we can as well just use what we call Pascal Triangle. How do we formulate Pascal Triangle? For Pascal Triangle, we always start with 1 and end with 1. After that, we always start with 1 again. We start with 1, we end in 1. But in this place, this one, we add these two together to give us the middle here. That is 1 plus 1. That gives me these two. Also for the third line here, I'll start with 1 and end with 1. But here, to get this one, I'll add this together, 1 plus 2, 3. I'll add this together, 1 plus 2, another 3. To the fourth line, I'll put 1 and 1. Here in the middle, I'll be adding the numbers together to get to the middle. All those one, I'll add together to get the middle. 3 plus 1, that is 4. When n is 5, I'll put it like this. This is 5. This is 10. This is 10. This is 5. When we add it, that is 4 plus 6, 10. 6 plus 4, 10. For 6, I can have, okay, we start from 1 and end with 1. So this is 6, this should be 15, this should be 20, this should be 15, this should be 6. And here, let me stop here. This should be 7, this is 21, this is 35, this is 35, this is 21, and this is 7. That here, when the power is equal to 1, when the power of n is 2, when the power of n is 3, when the power of n is 4, 5, 6, 7. We can generate it till eternity like that. You can see the way it's moving, like a triangle. That is why we call it Pascal Triangle, formed by who we call Blaise Pascal. Now, what is the meaning of this Pascal Triangle? I told you, instead of we to generate all this n combination 1, n combination 2, n combination, we use Pascal Triangle. Now, what this thing is saying is that this one means 4 combination 0. This 4 means 4 combination 1, 4 combination 2, 4 combination 3, 4 combination 4. Likewise, if I pick this 7, this one here means 7 combination 1, 7 combination 2, 7 combination 3, 7 combination 4, 7 combination 5, like that, to this place. So that is what we call Pascal Triangle. Now let us now use this Pascal Triangle to expand functions. Example 1. Expand the following functions. X plus y raised to the power 4 and this. For the first one, how do we normally expand? The first step is this. You see, the first one here, whatever that is here, we take this sign. You start it like this. You say x raised to the power 4. Move to the next line. You see, as if you have written this, after this now, you write x raised to power. The power will be reducing by 1, and this one will be increasing by 1, like this. You know, this is 4 before, it will now be 3. You put this one as 1. Let's say this one will be 0. You know, this one has taken 4. This one will take 0. So after that, this one will be reducing, while this 0 will be increasing. So that means the next one will have been s raised to power 2. This one will increase. This s will reduce to 1. This one will increase. And finally, this s will reduce to 0, while this y will increase to 4. That's our first step. In fact, let me pick the second question before we continue. The second question is s minus y raised to power 5. If you want to start without even looking at what is here, the first one is x, the second one is y, but whatever that is here, just look at it. The first one, we take this sign, this number, which is 5. This second one, this second value here, this second letter, or whatever that is there, that one will take 0. After that, this one will now be reducing, this will be increasing. The next one will have been s raised to power 4. This 0 will increase by 1. The next one will have been s raised to power 3. This one will increase by 1, that is 2. The next one will have been s raised to power, this 3 will now be 2. This 2 will increase to 3. And then the next one will be s raised to power 1, y raised to power 4. And finally, s raised to power 0, y raised to power 5. Now, I want you now to, let's say there's another one. S minus y raised to power 6. We have paused the video and solve it. What's your answer? Very good of you. This is what you are going to get. When you solve it on your own, you are going to get this. That is, this one takes the power, this one will start from 0. That's our first step. Now let's come back to the first question. You are taking the first step. What will be the next step? The next step now is you go to the Pascal Triangle, the fourth line, the one that has n is equal to 4. You go to the Pascal Triangle and memorize the numbers there. Now Pascal Triangle when n is 4, the numbers are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. This 1, 4, 6, 4, 1, you insert it beside each of the terms there. It will be 1, 4, 6, 4, 1. You do the same thing for this. That's the second step. When n is 5, you check the Pascal Triangle and put the values in each of the terms. Pascal Triangle for n is equal to 5. The Pascal Triangle will be 1, 5, 10, 10, 5, 1. Let's memorize it again. 1, 5, 10, 10, 5, 1. We insert it beside each of the expression, and that will become 1, 5, 10, 10, 5, 1. Likewise for the 6, if you check the Pascal Triangle, it will be 1, 6, 15, 20, 15, 6, 1. You can rewind and check the Pascal Triangle for 6. Now that's the second step. Again, our first step, we wrote out all these expressions. The second step, we inserted the Pascal Triangle. Now the third step now is you now consider the sign that is given. If plus is given, then you put plus all through in the middle. Plus, plus. But if minus is given, you use what we call alternating sign. That is, you start from minus, plus, minus, plus, minus. That is when minus is given. You observe that in this question, minus is given as well. So you start from minus. The next thing will be plus. This thing will be minus, plus, minus, plus. So that's the third step. Final step is to simplify this. Y raised to power 0 is 1. So it has no significance. What we have left is s raised to power 4. The second one will be 4. We are going to have this. When we simplify further, s raised to power 0 is 1. So it will remain ordinary. We don't need to write the 1. And this as well, When we simplify this one too further, we have this. And when we simplify further, we have this. So that solves the equation. Let's consider another example. Expand 2x minus 3y raised to the power 4. As usual, let's write. The first one is 2x. While the second one is 3y. The first one, which is 2x, we write it like this, is together. We take the power of 4. While the 3y, we take the power of 0. After that, the next thing we'll be writing is 2x, we take the power of 4. And this 4 will reduce by 1, that is 3. The next one, that 0 will increase by 1 as usual. The next one will have been 2x, we take the power of 2. While 3y, we take the power of 2. 2x, we take the power of 1. 3y, we take the power of 3. Finally, 2x, we take the power of 0. 3y, we take the power of 4. When we have done this, the second step now is we insert the Pascal triangle. For the Pascal triangle, when n is 4, I have, you can check it again, 1, 4, 6, 4, 1. I will put it beside it, 1, 4, 6, 4, 1. That's the next step. The next step now is that this minus is given. So you start from minus, plus, minus, plus. That is, you do that when minus is given, but if it is plus that is given, I will just put plus all through. The next thing now is this. Let us recall from indices that a b raised to power n is equal to a raised to power n b raised to power n. So that means if I have 3s raised to power 5, I can write it as 3 raised to power 5, s raised to power 5. So in that case, I can use this idea to finish my question. This one, all this now, forget about it. Raised to power 0. This one, forget about it, is useless there. So our answer will be, what is what we are going to have left? And now if I use the formula, I will have 2 raised to power 4, s raised to power 4. This one is gone, it's raised to power 0, it's 1, it's gone. Minus, the next one will be 4. This one will give me 2 raised to power 3, s raised to power 3. And the second one here will give me 3 raised to power 1, y raised to power 1. The next one will be plus 6 dot, this one, 2 raised to power 2, s raised to power, like that, you continue like that. But when we got here, this one is gone already, raised to power 0 is gone, this 1 is gone. What we have left will be 3 raised to power 4, y raised to power 4. Then we simplify this. How do we simplify it? Take all the numbers first. 2 raised to power 4 is 16, so we have 16 raised to power 4. So we have this as our answer. How do we get this? 96. This is 4. 2 raised to power 3 is 8 and 3. 4 times 8 times 3 will give me 96. This is s cubed and y. Also this is 4. This number here is 9, 3 square. Then 6 times 4 times 9 will give me 216. Likewise this will give me 216. I will just pick the letter. This is s square, y square, this is it. Also this one is ordinary s and y cube. This is it. Ordinary s and y cube. And finally 81 y raised to power 4. So that will be our answer. Let's consider another example. Find the expansion of 2s plus y squared raised to power 3. So solution. As usual, 2s plus y squared raised to power 3 will be, the first expression here is 2s. So let me take the 2s. It will take this power. Why that y squared will take power of 0. The next thing is 2s, we take the power of 2. Why that y squared, we take the power of 1. The 3 will be reducing, as usual. And then the next one will be the 2s, we take the power of 1. Y squared, we take the power of 2. And to the final one, which is 2s, we take the power of 0. Y squared, we take the power of 3. Now, The next thing is we go to Pascal Triangle. And when we move to Pascal Triangle, on the table, we should have 1, 3, 3, 1 for Pascal Triangle. So let's insert it. 1, 3, 3, 1. Now, the next thing is plus is given here. So it will be plus all through, plus and plus. So I cannot simplify. This 1 is gone. This raised to power 0 is gone. What we have left is this. And that will give me 2 cube s cube plus 3 dot. This one will give me 2 squared s squared. You can multiply according to indices, you just multiply the powers. Then y raised to power 2. 2 times 1 is still 2 plus the next one 3 dot. This is 2x, this one. And this one is y raised to power. You multiply the power, which is 4. Plus all these are gone. This is 1. This is raised to power 0, which is 1 as well, is gone. What we have left is this y. You multiply the powers. That is 2 times 3, 6. Finally, here our answer is 2 raised to power 3 is 8 s cube plus we multiply the numbers. 3 times this is 4, and that will be 12 s squared y squared plus multiply the numbers. 3 times 2, 6x y raised to power 4, and finally y raised to power 6. So this is all about binomial expansion for positive integer n. Let's now consider binomial expansion for any integer. It's given as this binomial expansion for any integers. We have 1 plus t raised to power n is given by this formula. You must memorize it as it is. When we are given 1, if it is of this form, 1 plus something raised to power n. So that is when we make use of this formula. 1 minus something raised to power n. That is when we make use of this formula. Let's take an example because this formula will be useful in that example. I want to expand square root of 1 plus s. So solution, we know by indices square root of 1 plus s is same thing as 1 plus s raised to power half. So in that place, my n is half and my t is x. So I'll make use of this formula here. You can see that it looks like 1 plus t raised to power n. 1 plus this raised to power n. So which formula are we now using? I'm using this formula. Our n is representing half, while my t is representing x, so that my answer will become 1 plus n. Our n is half, nt, our t is x, plus n into n minus 1, half into half minus 1, t squared, s squared. This is over 2 factorial, plus half into half minus 1. The next one is half minus 2. T cubed, that will be s cubed. Our t is x over 3 factorial. Now, if I simplify, this will be 1. 1 half times s gives me s over 2. This is the half. Half minus 1 will give me minus half. Our 2 factorial means 2. This is our s squared. And likewise this plus half, this is the half. Half minus 1 is minus half. Half minus 2 is minus 3 over 2. You can verify that. Why 3 factorial is 3 times 2 times 1. And that is our s cube. So finally, our answer will be 1 plus s over 2. This minus will come out. This is half, half, half. Half in 3 places, that is over 8. This will give me s squared over 8. Plus, because minus times minus here is plus. 3 cancel the 3 here. What we have left is half times half times half times another half. That is over 16. So our answer is s cubed over 16. To infinity, doesn't end. So that will be the first 4 terms of this expansion. So you can try this yourself. So we can expand the square root of 1 minus x. So you can do that on your own. Now let's consider another example. Now we want to find the first 4 terms of this expansion. 1 over 1 minus s raised to power 2. If you don't see it very well, is this 1 minus s raised to power 2. Now, so solution. This 1 minus s raised to power 2 by indices, I can write it as this raised to power minus 2. So in that case, my n is minus 2 and my t is still my x. So I will use binomial expansion for any index. I will use this one, the one that looks like 1 minus t raised to power n. I will use this. So this is the one we are going to apply. You can see 1 minus t raised to power n. It gives me this. So in that case, our answer will become, we follow the formula, which is 1. I will first write the 1. It follows by minus n. Our n is minus 2, so I'll put minus 2 here. It follows by t. My t is x. So you'll be using the formula like that. The next one is n into n minus 1. That is minus 2 into minus 2 minus 1 over 2 factorial. 2 factorial, you know that is 2 times 1. Then t squared. Our t squared is x squared minus, this one will give me, our n is already minus 2. Minus 2 into minus 2 minus 1 minus 2 minus 2 s cubed over, what we have there is 3 factorial. That will be 3 times 2 times 1. If we simplify further, this times this is plus. That will be plus 2x plus, if you look at this is 2 times minus 2. This one is minus 3. That will now become minus 2 times minus 3 divided by 2 s squared. Likewise, this minus 2 times, this one is minus 3. This is minus 4 over 3 times 2 times 1 s cubed. Let's say plus, but we say for the first 4 terms, 1 plus 2x minus 2 times minus is plus, is gone. So 2 over 2 is cancelled. What we have left is 3s squared. Likewise, minus in 4 places will become positive. Also, you observe that 3 is gone, 3 will cancel, 2 will be cancelled. What we have left is 4s cubed. So that is the first 4 terms of this expansion. You now observe that in these questions, the questions I've been giving, I'll be giving 1. Let's consider the one I'll be giving 1. That is why I can use this formula directly. Let's consider the one that has no 1 here. How do we deal with it? This example, find the first 4 terms of this expansion. You can see here, there's no 2 here. There is no 1, it is 2. How do we do it? We need to manipulate. Our aim is to make this place to be 1 so that I can make use of this formula directly. But if you look at this, you see that this is 2, it's not 1. The first thing is, you should know that if I factorize this thing that is here, I'll bring 2 out. This will give me s over 2. So that if you expand it, 2 times 1, this is the 2. 2 times x over 2, it will give me x. So that means what I write here is still the same thing. Then I can apply indices there. The indices says, I will write it as 2 raised to power 3 and 1 plus s over 2 raised to power 3. I have successfully obtained 1 in this place. So that my answer will give me 1 over 2 raised to power 3 times 1 over 1 plus x over 2 raised to power 3. If you now simplify further, this is 1 over 8. By indices, 1 over something by indices, this will give me 1 plus s over 2 raised to power minus 3. When this one goes up, we have this. From this place, we now observe that my n is minus 3 and my t is s over 2. My n, this is my n, this is my t. Don't forget that there is a constant here which is 1 over 8. Our answer is 1 over 8 into whatever the formula will give me. This is the formula once again. The formula is 1, it starts from 1 plus nt, and that will give me 1 plus our n is minus 3, while our t is x over 2 plus n into n minus 1 over 2 factorial. Minus 3 into minus 3 minus 1 over 2 factorial is 2 times 1. Then what we have here is t squared. This is our t. That is s over 2 all squared plus n into n minus 1, n minus 2, that is minus 3 into minus 3 minus 1 minus 3 minus 2 over 3 factorial, that is 3.2.1. Then s over 2, that is t cubed. From this place we can simplify further and we get, so we have this, we simplify further to get what is here. This is minus 3 minus 1 is minus 4. This is it. S squared over 2 squared is s over 2 squared is s squared over 4, because 2 squared is 4. Likewise, this is minus 3 minus 4 minus 5. This is it, over 3 times 2. S cubed over 8, 2 raised to power 3 is 8. And we have this as our final answer. General term of binomial expansion. So this is the formula for finding general term of binomial expansion. That is when we are given expansion of this form, a plus b raised to power n. Now what are we using this formula for? We use it to find a certain term of an expansion. For instance, here we have to find the fifth term in the expansion of this. To find the fifth term in the expansion of this, normally, if I don't know anything about this, the first thing is I'll first expand it raised to power 9. And if I can decide to give you raised to power 16, that means you need to expand it raised to power of 16 using Pascal Triangle. Finally, you now look for the fifth term. That will be cumbersome. But using this formula, it will be easy for us. How do we make use of this formula? The first thing is we need to know in the formula I have n, I have r, I have a, and I have b. In this formula, I need to know my a. The first one here is my a, this is it. Here is my b, this is it. And here is my n. Then what is my r? I've known other variables. I need to know my r. R is close to the term you are looking for. The term I'm looking for is 5. Then if you are looking for the fifth term, your r is 4. If you are looking for the seventh term, your r is 6. If you are looking for 11th term, your r is 10. Definitely, I'm looking for fifth term. Definitely, my r is what? 4. I will now use the formula. The formula is n combination r, that is 9 combination r. This is it, 9 combination 4. A, this is my a, raised to power n minus r. This is my 9 minus 4. And b, our b, this is our b, this is our b here, raised to power r. This is our r. And if you simplify, we have known how to find 9 combination 4. That is 9.7.6. 9 minus 4 is 5. If you simplify further, this one and this 81 will give you 6804. S raised to power 2 raised to power 5 will give me s raised to power 10. And y raised to power 4. That's our answer. Let's consider another example on this for better understanding. So we want to find the 8th term in the expansion of this. The first thing is I need to know my a. My a is 3x, this one. What's my b? My b is this one. Minus y squared. My n is 11. I need to know my r. We have to find 8th term. Definitely r is 7. So since r is 7, I will use the formula. Let me write the formula here once again. The formula is n combination r, a raised to power n minus r, b raised to power r. Then the 8th term will now be the formula n combination r. Our n is 11, that is 11 combination 7. Dot, what's our a? 3s raised to power n minus r. 11 minus 7. Dot, minus y squared raised to power r. Our r is what? Our r is 7. Then 11 combination 7, we know that 11 combination, as I have explained, is same thing as 11 combination 4. Because 4 plus 7 will give me 11. So dealing with this and everything we are going to have, so we should get this. 11 combination 7 is same thing as 11 combination 4. And that will give me this. 11 minus 7 is 4. 2 times 7 is 14. The minus still remains. You know that this is 3 raised to the power 4, x raised to the power 4. 3 raised to the power 4, there, 3 raised to the power 4 is 81. We note that 3x raised to the power 4 is the same thing as 3 raised to the power 4, x raised to the power 4. 3 raised to the power 4 is 81. That is 81 times all this will give me 26,730. You can use your calculator for that. The minus is here, and we have x raised to the power 4 and y raised to the power 14. So that will be the answer. It will be the 8th term in this expansion. Let's consider another example. Another thing we normally use general term to find is find the coefficient of x raised to the power 3 in this expansion. Now, in this case, as usual, our a is here, this is our b, this is our n. But in this case, when you are finding coefficient, r is not known because you are not finding term. Our aim now is to find r. If you have known r, then we are there. Let's use the formula again. The formula is n combination r, a raised to the power n minus r, b raised to the power r. So our answer is ur plus 1 equal to, use the formula n combination r, 9 combination r, which you don't know. Then the first one, n, a, our a is x raised to the power n minus r. Now our n is 9. We don't know our r. And this one is this raised to the power r. This is our b raised to the power r. We are now left to simplifying all this. This is 9 combination r, x raised to the power 9 minus r. This one is same thing as minus 1 raised to the power r, x raised to the power minus r. Because 1 over s is same thing as x to the power minus 1. And minus 1 times r is minus r. If you are applying indices for these two, you are going to have x to the power 9 minus r minus r. When we apply indices, minus 1 raised to the power r. Now, our aim is to find the value of r. You now come back to the, if you have simplified it, you come back to this question. The question says find the coefficient of x raised to the power 3. Your aim is to make this place to be 3. Because they ask you to find the coefficient of x raised to the power 3, you will now start by saying let 9 minus, this one is 2r. Minus r is minus 2r. Let it be equal to 3. From that place, if you make 2r the square formula, it will be 9 minus 3, which is 6. If you make r the square formula, r is 6 divided by 2, that is 3. Now we have known our r. So our answer will now be 9 combination r. Our r is now 3. 9 combination 3. X raised to the power, you have said let all this be 3 already. Minus 1 raised to the power 3. 9 combination 3. You know that one will give me 9 times 8 times 7 over 3 factorial. X raised to the power 3 and minus 1. Simplify all this. This is minus 1. It gives you minus 84s cubed. But my question is coefficient of s cubed. I can now conclude that therefore coefficient of s cubed is minus 84. That's our answer. Let's consider another important example on this. Consider this. Find the coefficient of x raised to the power 7 in the expansion of this. Here, our a, the first one is s squared. This is our b plus this. This is our n. We don't know r. When it comes to coefficient, we need to find it. And using the formula, so we have this. Our answer is n. What's our n? 11 combination r. We don't know it. A, what's our a? S squared raised to power n minus r. Our n is 11. Our b is 2 over x raised to power r. We don't know it. So that this thing becomes 11 combination r, s raised to power. If you expand this, it will be 22 minus 2r. 11 times 2, 22. r times 2, 2r. This will give me 2 raised to power r over s raised to power r by indices. This is 11 combination r. By indices, you know, division turns to minus. So that my answer is s raised to power 22 minus 2r. This division will become minus r again, times 2 raised to power r. Now, we come back to the question. We are looking for coefficient of s raised to power 7. That means we have to make the whole of this place to be 7. The whole of the power. In that case, I will now say let 22 minus what we have there is 3r equal to 7. 3r will be equal to 22 minus 7. 3r equal to 15. Therefore, our r is equal to 5. Our aim is to find r, and we have known the value of r. Therefore, the uses becomes 11 combination, our r is 5, times s raised to power, our aim is to make this place to be 7. So it will be 7 automatically. Then 2 raised to power r, our r is 5. Our aim is now to simplify this and this together. And that will become, that will give me 14784 s raised to power 7. But my aim is to find the coefficient of our question, coefficient of s to the power 7. I cannot say that, therefore, the coefficient of s to the power 7 is 14784. So that's our final answer. Let's consider the last question on this. Now, find the constant term in the expansion of this. You can be given in two ways, in different ways. We can say that find the constant term in the expansion, or they can say find the term independent of s. Term independent of s. Term independent of x. I can say that find the coefficient of s to the power 0. It's still the same thing. Now, as usual, our formula is ur plus 1 is n combination r this. So from that place, our ur plus 1 is n. Our n is 12. Combination r, we don't know it. Our a is s squared raised to power n minus r. 12 minus r. While our b is 1 over s squared raised to power our r. We don't know it. This will give me 12 combination r, s raised to power. If you simplify this, it will give me 24. 2 times 12 minus 2r. And by indices, this will give me s raised to power minus 2r. When we simplify further, we have 12 combination r, s raised to power 24 minus 2r, that is minus 4r. Now, if the question now says find the constant term, it simply means find the term that has no s at all, or find the coefficient of s raised to power 0. In that case, you make this place to be 0. As we are letting that place to be a value, since for this case, you only say let that place be 0. You now need to find your r. 4r is equal to 24. Therefore, r is 24 over 4, which is 6. Since r is 6, I cannot come here. Then the u7 will be 12 combination r. What's our r? 6. S raised to power 24 minus r. That will be 0. We don't need it again. So finally, the constant term will be 12 raised to power 12 combination 6. So you should find that assignment. So that is that about binomial expansion. It's on binomial expansion. You can pause and check it. This is the Pascal triangle that we showed the other time. We have examples here. This is the formula that I gave you for any index. We have examples here. We have example here. This is general term. That's the formula that I gave you. You can pause and study these examples. Practice all these questions.